Hi, good afternoon. Welcome to UTA Planetarium's live star stream. My name is Levent Gürdemir, UTA Planetarium Director, and Jim Bader is with me, Planetarium Program Coordinator. We'll talk about what's going on in space, and we'll answer your questions through the chat. If you have any questions, you can interact with us. I can see a few are regulars. Hi, Braxton. Hi, Kurt. Good to see you. And I think we'll talk about James Webb Space Telescope,
we'll
right?
talk about that, but we'll get to that in a moment.
Okay.
We're just ignoring that little code up there.
All right. So let's talk about what's going on with the space, Jim.
Yeah, we have a lot of cool space stuff to talk about. But I guess before we jump into the cool space stuff, we have some announcements, some changes to the website, right? We want to talk about.
Yes. Now we have a donation option on our website. If you like our live streams, if you like our planetarium, please visit our website. And if you would like to donate any amount, you can use the link at our main web page. Says donate to the planetarium. So any donations are much appreciated. With more donations, we can do a better quality live streams, better quality planetarium shows, because we are always upgrading our software, our hardware, and it takes a lot of things to make these programs possible. And also, Jim posted the links on our chat. If you, rather than visiting our website, you can directly find the links on our chat too. And what are the space news?
Space news. Okay, so first of all, just to say it, Jennifer was the one who posted that. We're very lucky. Maybe you said Jen. Jen and Jim are so close together. What can we say? But yeah, let's jump into the space news. So here we go. We have a quick comment from Brexton, who thank you, Brexton, for being here. Always good to see a familiar face. Brexton says, how do we get into the virtual tour of the planetarium? I think you're referring, Brexton, to our virtual field trips. Do you want to talk about that, Levin?
I think I said like our virtual programs.
Oh,
and our virtual programs is just like live stream, this live stream. We are also doing virtual field trips, but those are offered for K through 12 schools. Public doesn't get into those virtual field trips. But yeah, virtual programs, I mean the public live streams.
We did just post recently a kind of an ad, I guess you'd say, for the virtual field trips, and those are definitely for field trips.
Yes.
It would be a little weird to have the general public pop into one of those, or to do a program like that for one or two people, as they're meant for school groups. But yeah, if you're a teacher and you're watching this, book us for a private field trip. They're awesome. We have a lot of fun. We do a lot of stuff we don't do for our live streams for these things. It gets pretty wild. I think we've had Levent turn into a piece of spaghetti and go into a black hole before. We could do it again, I guess. Anyway, space news. James Webb Space Telescope. We have some cool updates.
Is that the one I see in the background?
That's the one. I should move out of the way. Let me. Whoop, there we go. James Webb Space Telescope event. It's still planning to go into space this year, which is good news. This is well, what's so funny? What are you laughing at?
Do you know what was the year that's supposed to be in space? 2007.
Oof, big oof. Oh,
they started designing this in 1996.
Well,
supposed to be in space in 2007. And I don't know why I'm talking about still this telescope in year 2021.
We're supposed to launch
They are
it
still on
this
the ground.
time. There's no doubt. There were so many delays with this space telescope. It's a big project, though. What they're doing is a leap, right?
When you look at the Wikipedia information about James Webb Space Telescope, it says, it was going to be launched at this date and delayed. Launched at this date, delayed. Delayed again, delayed again, delayed again.
I should bring that up later. Just bring up the web page for us. no doubt there's been delays, but it's going to be. I mean, they're going to put it so far from Earth, right? It's going to be on the other side of the moon in that Lagrange point. We talked about this before, so it's a kind of a daring thing. I'd be scared to, especially if it's federally funded. I mean, I'd be scared to have something go wrong with it, and then hey, I know you're a taxpayer, but we accidentally lost billions and billions of dollars. Oops. We got a comment from Brexton. He said, will they ever recover any of the space debris that landed in the Indian Ocean? Did you see that, Levin?
I heard about it. I did not see, but
Just missed the Maldives.
We talked about it last week, right? And we
Yep.
said like that debris will land or can land anywhere. And also we said because 75% of our planet is covered by water, so that means 75% of chance that it will end up in water, which it did. So the science worked. Indian Ocean.
Just crazy. But it was good that it didn't. I mean, it didn't hit any large land mass. People speculated it's possible that some of the islands in the Maldives caught a few chunks of it, but no reports as of now.
I can be wrong, but I don't think anybody will attempt to recover any debris if there is something that worth to secure, or maybe some. Sometimes like confidential or proprietary secret type information or technology. So I don't know. I mean, then it may worth to recover, but otherwise they would just leave it alone.
Those boosters that China, the stuff that it came from, the what is it, Long March, Chinese Long March rocket that they used to launch with. 5B. Jennifer is informing me. Anyway, those when they often launch in the U.S., we put all of our launch facilities on over the water, so that when we let debris fall, we can let it fall into an ocean. It's not going to hit any people. It's a positive thing. But often in China, as they don't have good waterport spaceports, those things just hit neighborhoods and communities and villages in China. There's videos and pictures online you guys can find. This is real. It's kind of crazy. I don't know if we're just fortunate or maybe we're just a little more cautious, but
let's move forward about this one, because I'm not too excited when I see something about James Webb Space Telescope.
We gotta mention it. It's doing its last test. We didn't even talk about the news. It's doing its last test. It opened its mirrors.
I will get excited when I see it in space because it doesn't give me any use on the ground. This telescope is a large telescope which is supposed to replace Hubble Space Telescope. So Hubble Space Telescope is the only eye in space. So it is the only telescope able to provide visual pictures to us. So that telescope is a lot better telescope than Hubble Space Telescope, a lot larger telescope by design. Of course, on the ground it is useless. Hubble is at least, it's an old telescope, but it is in the orbit. So, and the design of this telescope started shortly after Hubble is in operation. So because they said, well, with the success of Hubble, they started seeing a lot better and clear images of the planets of the solar system, of the distant galaxies, of the many other things in the space, star formation regions, Orion Nebula, for example. And then they said, well, it's a great thing to have a space telescope, so let's build a better one, because Hubble is the first one. It has only 2.4 meter wide mirror, so let's do a better one. But this telescope was designed, again, they started designing this in 1996. And here today it is 2021. Well, it's still on the ground.
Yeah, before I switch to the next one, I just want to point out how ridiculous the engineer or technician above your head looks. Just barely hanging on to that arm. It just looks ridiculous.
Braxton has a good question. How
Okay.
far will it go out in space?
Far.
Well, Hubble Space Telescope was designed to be just like a commercial TV satellite. It is just
Wait,
orbiting.
the James Space Telescope will go like 1.5 million kilometers.
Let's say it this way. It is
L2.
going to be 3 times the distance of Earth and the Moon.
Yeah, far.
So the Hubble Space Telescope is still in the actual layer of the Earth's atmosphere. It is pretty close, and it is orbiting around the planet just like a TV satellite. The James Webb Telescope is going to be a lot farther. So it will exceed 3 times the Moon distance. And it is going to be sitting on a very special point called Lagrange 2 point. If you don't know what Lagrange 2 point is, so it is a very interesting point. It is one of the 6 points around Earth that the forces from the Moon and the forces from the Earth, the gravity forces we are talking about, that cancel out, that anything you put in the Lagrange point will stay stationary without requiring additional energy or power.
Yep.
So this is a special point. You cannot explain that. Lagrange 1 point is just between the Moon and Earth, or the Sun and Earth. So it is very easy to explain. We have actually a satellite over there called SOHO, Solar Observatory. So it is very easy to explain physically. But with the vector physics, you cannot explain the Lagrange 2 point or Lagrange 3, 4, 5, 6 points, because they are on the different side of the object. So it is very interesting point. It is far from Earth, but the James Webb Space Telescope will not require additional energy to stay on the orbit. And it will be very far from Earth. That brings a lot of benefits to a space telescope, because the Earth itself is creating a lot of noise. That's not like the sound noise that it provides. We are talking about thermal noise, like a heat energy. So that heat energy is affecting the instruments around Earth. It will be far away, and it will not be affected by the noise, the thermal noise of Earth.
Yep. Kurt had a really good question.
Mm-hmm.
I think that we should definitely talk about. Kurt's question was, so is all the technology on the Webb scope from the original plans, I think he's referring to like 1996, or did they upgrade and modify things as they developed over the years?
Well, if they did any modification, that would be for the electronics and the sensors. Well, the mirror technology remains the same for over the decades. They didn't change the size of the telescope. We actually talked the new design of this style. This is like a honeycomb design. They made it that way because the manufacturing one large mirror like this requires precise engineering, and still there is a lot of problems with it. So they make the mirrors consisting of individual segments. Each segment is computer controlled, precisely aimed, so they can align the light paths, and they can get rid of a lot of light artifacts. So that's a very cool technology. It's been around for many decades. It's not a new technology. Nothing is upgraded in the reflective surface, but of course the electronics, the storage devices. How amazing, right? That we talked
Since
about
1996, storage capacities in terms of size.
yeah, we talked about Mars Pathfinder in 1996. The rover landed on the Mars surface, had only like 4 megabytes of storage. So today it is pretty much like nothing. Probably your watch has a lot more memory than Pathfinder on Mars.
Yeah, definitely. That storage capacity over the years is, I mean, you and I have talked about this in the office way too many times, but it's pretty crazy.
Yep.
What has happened with it. Anyways, let's jump on to the next news story, because we were just delaying. So without further ado, here we go. Are you ready for this update? In case you're out there and you're testing engines and other space transportation devices, Space Force is seeking bids for rocket engine testing and transportation technologies. I just thought this was a ridiculous news article. For me anyway, that is kind of advertising like this. I just feel like if they're looking for people, they would just reach out to the primary producers. You know, hey, Raytheon, Boeing, L3, all these people who make rockets and missiles and other things.
Well, I
Um,
plan to bid on that too.
That's what I figured, right? Maybe we're going to have a planetarium bid. We're all going to just get together and reach out to, I mean, Jennifer's a aerospace engineer, right? We have lead engineer. We're good. I think. I'm kidding. I don't know if I'm allowed to say that. She works for a company now, so maybe we're not allowed to sell her.
Well, look from the good side. For entrepreneurs, that would be a great investment, or not investment, but innovation opportunity, right? Maybe, I mean, it may be like a dream, but someone can start their engineering company and bid for one of those things. And if the bid seems to be reasonable, and the people can just really prove themselves, they may be honored with the bid.
Yeah.
And
yeah.
then there may be a company can start like the innovation and technology company
There's
who
several
makes rockets.
smaller rocket companies that are trying to do these innovations. There's several of them that we don't really hear about very often. I mean, you hear about the major ones, you know, ULA, United Launch Alliance, and you hear about SpaceX, and you might hear about Blue Origin.
Kurt mentions that his first computer was 16 kilobytes of that. Was it Commodore 16? I'm just curious.
We'll wait for his response. But hilarious either way. Yeah, no. Just to tell you, Kurt, Space Force is a military branch. It is a real one now. It exists. It's not a joke anymore. And it's fully there. I mean, Space Force is the one who is tracking that Chinese rocket debris. They're the ones who said when it was it was a TRS-80.
The computer,
Yeah.
probably. Yeah.
I don't know what that is at all. Doesn't sound very powerful. Probably not going to play World of Warcraft on that computer. Just me? Okay. Anyway. Sorry.
That computer is probably older than you are, Jim.
Yeah, probably.
Just Google it and find out what
I will definitely
TRS-80
go. Hey,
is.
we actually have an alert, an update, space weather update. This is important, I think. Space weather alert. Look at that. Really, we do. So let's go ahead and just pop over there. Let me get rid of that other image so that we can just kind of black this out. And I need to disappear. One of our space physicists here at UTA, Dan Welling, just tweeted a little bit ago, the ongoing space weather storm is looking like a good one. So there's been some space weather activity over the last few, maybe not minutes, but last while. And the sun has kicked up to like 4 times what it typically would. So we have a whole lot of space activity, and we're getting a lot of it. You can see a huge spike there that happened this morning. And as stuff's coming in, it's looking like we're actually, it's probably a good thing that it's going to subside by this evening, but in a bad way. That also means if you're somebody who wanted to see the northern lights and you live in the northern latitudes,
Yes.
bad news for you. You don't get to see it, unfortunately. Pretty neat, though. Is this something that happens often, Levant, that you can talk about? I mean, that we get heavy storm, solar storm stuff?
Well, we don't know when they are getting heavy. That's why we are observing constantly the sun, because storms are coming from the sun. So the space weather may be a strange title for many people, because like the weather in space, if there is no air, how come we talk about weather and storms? So these type of storms are actually, we are talking about very highly energetic particles that are coming from the sun. So the sun is not providing those particles constantly, because the sun is not like if you look in detail, not very like stable star. So at the surface level, the sun actually looks like a boiling pan, that like a water boils and rises and goes down, and at one point sometimes just the flares happen on the surface of the sun. So when the flare happens, it's just like a big bomb going on the surface of the sun, and this bomb actually sends a lot of very fast moving but tiny particles all over the place. So, and sometimes it sends fireballs too. And we have in the past 10 years, a few really close misses of these fireballs. So, but there's something that protects Earth, our planet, from these highly fast-moving particles, and that's the magnetic field. So our Earth acts like a magnet. There's a invisible magnetic field around the planet, and that magnetic field is like when you hold the piece of iron or steel close to the magnet. What it does is it just pulls, right? It attracts,
Sure.
It pulls on it and sticks on it, and the magnetic field around Earth does the same thing. These highly charged particles, fortunately, they are charged. They are carrying electric charge. So when an electric carrying charged particle gets close to a magnetic field, it diverts its path towards the magnetic field line. So that diversion makes the charged particles misses our planet, but they don't just go and get deflected. They are deflected towards the pole of the magnetic fields. So when they are deflected to the pole of the magnetic field, where are the magnetic poles? They are close to the north and south poles, the geographic poles of Earth. So that's where we get to see some interaction between the air molecules and the highly charged particles. And as a result, we see northern lights, because as the charged particles start interacting with the water molecules in the air, they start giving off light. They just start releasing their energy, and we see like glowing clouds, glowing lights in the sky in the northern regions.
Are auroras?
Auroras, yes.
Borealis
Northern
and
lights
australis.
or auroras. So if you remember talking about Dr. Welling's presentation when we had him as a guest speaker at one of the live streams last year, he talked about a strange deviation in the magnetic poles. So they deviate at a rate that it is expected, or the rate is more than expected. And he says it may also possible that the polarity may reverse suddenly or in short amount of time, because they have evidence that it happened before, past in the history. And if it does, we don't know how this is going to affect all the protection shield around Earth.
Yeah, that seems like such a massive thing. But I remember him talking about and saying like, we don't expect to see anything crazy, but we really don't know.
Yeah.
And it just seems wild that the poles, the polarity, which you can't really say poles are going to flip, because you're imagining like physically stuff's going to flip, but the polarity is going to switch. That seems like such a dramatic thing. But when he said like, oh yeah, we don't really expect much to happen, I was sitting there, I mean, obviously not on camera, but just like, what? Yeah, it shouldn't be a big deal. Okay.
Well, and there are a lot of unknowns, question marks. It is not possible to say, oh, everything is going to be fine, because that type of radiation or type of the storm is damaging the communication satellites, and sometimes the power grids got affected. Yep. Because the particles are carrying electrical charge. When they get so strong and so close to our planet, they are able to affect the power grid lines, because the power grid lines are also carrying electric charge, and they interact with each other and causing electric grids to catch fire.
We've had that happen in the past, right? We had some pretty crazy stuff going
on. In early 1900s, there are some
they're
power
like
lines.
Phone towers. It like burn up phone cables or something.
Yeah.
Anyway, we have some funny update here. Here's the computer. Look at this thing. It looks beautiful. It's so trendy. If you had this, Kurt, today, this is Wikipedia, by the way. We can't vouch for the accuracy of what we're looking at. I didn't do too much research into it, but boy, you could sell that on the Facebook Marketplace for some heavy change.
There is no mouse.
What?
There is no mouse. And you don't see a lot of graphics on the screen. It is mostly text. And this is a CRT monitor,
It's
very small.
beautiful.
And it is a single color monitor, mostly green.
Oh, I remember that. Just green text. That was like the standard for a long time, I think. Looks beautiful though. Yeah, there it is. 43 years ago. So that's older than you, right? Am I wrong?
Yes.
I don't know if I'm allowed to say that publicly. Should I have
Yes.
not outed you there?
Yes, I am 40.
Well, so yeah, happy 40th
No mouse,
anniversary.
and he says the data was recorded on magnetic tape. That's also another thing,
Oh, magnetic tape.
It's like not even like the floppy disks. I don't know if maybe many of our audience may not know what floppy disk is.
It's the thing that they modeled the save button after, Levent. I know what it is.
I have floppy disks in my office from old days.
And I'll never not give you a hard time for it. Why do we still have those? And I'm kidding. I'm kidding. Let's move on to a news article. All right, we actually had some important questions first, so I am gonna skip past this. We're gonna move over, but good questions about the sun stuff. So Brexton asks, wonder why there isn't another planet like ours with the same magnetic field. That's good because we have some new data on Venus, right?
Yeah, there are other planets with magnetic field, but the magnetic field thought to be related with the originating from the moving currents inside the planet. So that means the more liquid the interior is, the more likely the planet have strong magnetic field. On some planets, we don't see strong magnetic fields because, like, if there is no volcanic activity, we know there is a completely molten magma layer inside of Earth. But that's not the case for the planets, because to keep the molten magma layer, the planet needs to be under some gravitational disturbance, such as moons going around the planets. So if there are no moons going around the planets, or moons are tiny enough, so they are not really disturbing the interior of the planets sufficiently, so those planets are cooling down, turning into a stone in the interior. So those planets are not showing as any magnetic field, because you need like the electrical charge rotating inside of the planet to be able to have the magnetic field.
That's kind of like how we assume that Venus has a much less active core than us, right?
Yes.
And Mars is the same.
Yes.
It's pretty neat.
Yeah.
Kurt had another good question that he said, I found it amazing that there's enough fuel in our sun to support nuclear fusion at that magnitude for millions of years. It seems like something burning so fast would run out of fuel much more quickly. I think maybe, and this is something that blows my mind too, Kurt, the number of molecules in the sun is nonsensical.
That was also a very good question for astrophysics 101 questions. Like, what can be the source of the sun, the sunlight power? So you can calculate. You can just imagine you can put gas and fill it up all the interior of the sun and burn it and find out how much it's going to burn. Or you can think about coal energy. So we all know how much energy they produce per second, they produce per minute, right? So we can do the same calculations for coal energy. Also, because the sun has a huge gravity, that also produces the heat energy. So that heat energy can be also a contributor. But we find out that the nuclear energy is the most likely source, and also all the evidence supports that. We know it for sure today that it's the nuclear energy. For the nuclear energy, you don't have to have a lot of or big number of molecules. Right? The sun has big number of molecules, but because the intensity of the nuclear radiation is so intense, very small, like the nuclear bomb is made with very tiny amount of the elements. Because if you remember the Einstein's famous formula, E equals mc squared, c here is the speed of light, which is a very big number. So it is squared times mass in grams. So even 1 gram produces the energy that, I mean, you can, if you just turn it into a bomb, that's a very
yeah, a lot of energy.
A lot of energy bomb. So so that's what's going on in the inside of the sun. And every time, if we speak with the numbers, every time as we speak, every second, 4 million tons of hydrogen is going into a chemical reaction or nuclear reaction and turns into 4 million tons of helium. So there is not much mass loss on the sun, but there's a tiny mass loss actually. It is like a very small number, but 4 million tons turns into approximately 4 million tons of helium. So what happens to the tiny little mass difference between? E equals mc squared. If you just take the m and multiply it with the speed of light squared, and that much energy is being produced at the core of the sun every second.
Pretty crazy, pretty crazy. Lamia, thanks for your comment. Yeah, we got. She just sent us a floppy disk, an image of a floppy disk. I use one of those as a coaster. Who knows? Who would have ever guessed that it?
What
held
type
data.
of floppy disk? They were like the 5 1/4 floppy disks and the
I can
3
show
1/2 floppy
ready?
disks.
Here it comes.
Okay, this is 3 1/2.
This is the image you
The
sent.
older versions were bigger, even though the storage is a lot less. This is 4.44 megabytes, not giga or tera.
1.44, right?
1.44,
Yeah.
yeah. The old ones were only 360 kilobytes, but they were reversible. So you can just put this side and record your data, and when you run out of storage, just take it out, flip it up, and put it back again. So you have empty disk if you flip it over.
Oh boy.
So then they invented the dual head floppy drives. It can read the both sides, and so on.
Well, boy, am I glad that we are where we are today in the future, because 1.44 megabytes, that's not even a picture. It's not a song.
You cannot even put your Word document in it.
Yeah,
today.
it's just nothing.
But they used to store the entire operating system in these floppy
It's silly.
disks.
I know. I remember getting Windows 95 on a whole bunch of floppy disks. Those floppy disks in particular. You probably could get it on a CD, but
In my museum
Okay, I had
collection, I have Windows 3.1 in floppy disks. 7 floppy disks.
is that where we're going to start? We're going to start a UTA floppy disk collection museum, the world's largest floppy disk museum, only at UTA.
Yeah, probably if I can find all my floppy disks, they would worth a museum piece.
All right, quick. We're running. We went way over time, so we're gonna burn through these last 2 updates. Small one, but interesting. Our little spacecraft has left Bennu, so we've been at Bennu for a while, and it is now officially heading back to Earth, which is neat. We're gonna get a sample of the asteroid Bennu soon. Very excited about that, and then. Moving on, we have, as we always do, we get to say, and I've got to do this carefully so you guys don't know what we're doing here. Ready for it? All right, Perseverance update. You never would have guessed. Never would have saw that coming.
I almost forgot about this flying on Mars.
We don't have to talk about the flyer this time. Ginny has been bringing back fantastic results. It can fly on the surface, but we get to say that Perseverance is finally starting to do science. So you just stood right in front of Perseverance. You got to roll back over there to your something, your left or right or. You still just go back to where you were. It's perfect. There we go.
I will just go on. There's not much space
Exciting
for me in the
update.
screen.
Anyway, yeah, it's been doing a lot of research, a lot of cool stuff that it's bringing up. It's been taking photos. It hasn't been just sitting there dormant. So here is some of its photos. This is Santa Cruz Hill. I'm kind of in the way, so let me pop out of here. But it's been really just acting lately as a beacon to transport data from the helicopter. But now it's starting its research. This is crazy, this photo. I mean, looking at these rocks.
Do I see a trail here?
It looks like it, but I don't think it's a trail. I mean, it hasn't gone very far, but I agree with you. I'm just seeing that too. As you were looking at it, I was seeing this trail. This is relatively fresh images that we're looking at. So not that this stuff hasn't been seen, but that it is fresh stuff. So this Santa Cruz Hill this photo was taken not too long ago. I think Sol 68 or something. So it's 68th day on the surface. Relatively recent, this photo is. But seeing these photos just blows my mind. All those rocks. I mean, this is just wind-eroded rock all over the place with the Martian sand, too. So pretty crazy-looking stuff to me. It really blows my mind. And we have another up-close one, too. So here's these rocks. And just to remind everyone that Perseverance is there to look for life. It's the only science mission we've sent with its primary mission is to look for signs of life in the past, not actively, but in the past on the surface of Mars. It's going to be studying rocks, looking for any traces. It's pretty exciting, but hopefully in the coming weeks we get more science updates, more news to talk about in regards to Perseverance's primary mission goal. But anyway, that's it. Any other important stuff we missed, Levent?
Nope, I think we covered all, and we are running out of time. But if you have any questions, you can either send it during the week or just join us with the live stream next week, and we'll be here. And again, just feel free to visit our website for and donate if you can, or invite some others to donate, because always we are trying to improve everything in the planetarium. And if you like us, of course, just share our live streams with your friends, or just make them like our videos.
He said make them like. That make them part. We
Encourage.
don't condone with force.
Let's say politically correct way. Encourage them.
But I wouldn't be mad
like
about it if you did make them like it.
All right. Well, we'll see you next week, and hope to see you, everyone.
All right. See you all.